Hello and welcome to the RSTP video. Now, the keen-eyed among you may be thinking, hold up Dickie, this topology looks a little bit different to what the last video was, and you would be correct. I've swapped to EVE-NG, or PNetLab in this case. I found sometimes when you're doing layer 2 switching, it runs better in EVE-NG than it does on GNS3 for some reason. It's just one of those weird things. So where we're at the moment is we have our basically where we was before. So we've got our switch 1, switch 2 and switch 3. Now these are, as you've probably gone through the rest of the course already, you'll know these are dual node setups, but these are the QFX data center switches. So the downside is you can't get EX series switches virtualized, so you can only really do switching either on a SRX firewall or on the QFX. So I've just loaded up some QFXs here, and we've got our 3 PCs, and we're at the state now where there's no spanning tree running on this, and we'll go through the configuration and have a quick look. So let's bring up switch 1 and have a look on switch 1 first. That says switch 3. Switch 1, and let's do a show configuration. Configuration. Alright, so we have our interface, which we can see here, our XE000, which is going to switch 2. It's our interface mode trunk in the Ethernet switching family. The VLAN members is all. XE001, which is going down to switch 3, again Ethernet switching family, it's trunk and its members all. And what we have here going to our PC1, we have again the Ethernet switching family, but our interface mode is access, and the VLAN members I've just named this default because that is VLAN 1 is called the default VLAN by default. I haven't added any extra in here. If we do probably go through some VLAN spanning tree, then yeah, we'll add a couple of extra ones in here. So all the other switches are the same. Interested to see if we can ping across, because at the moment seems that we have no no RSTP, no spanning tree running. We have a loop between switch 1, switch 2 and switch 3. So let's see if we can ping 10.10.10.2. no, that doesn't seem to want to work. We've got one going through. We've seen this before, however. You'll get the odd one going through, but at the moment these packets are spinning around this 3 switch network like crazy. All right, so let's go and add our spanning tree in. So let's go into configuration mode, and again this is exactly the same as how we done it for the service provider MX series devices. So set protocols, RSTP, rapid spanning tree. If you do the question mark here, you can still do the force version right here if you wanted to change it to normal spanning tree, and you still have your bridge priority. So if you want to amend the priority of this particular bridge, then we can do that. However, we're going to let spanning tree figure out its own priority, its own route on this. And now we're going to do, as we've done before, we're going to go interface and put our interfaces in. So we go interface, and it's going to be XE 0/0/0, so that's our link to our router to switch 2 rather, and 1, which is our link to switch 3. And let's commit that. As you see, very straightforward. There's no difference in the configuration or even the monitoring of spanning tree between the switches or the actual MX series routers. So configure, so set protocols, RSTP, interface, XE 0/0/0 and 2, and commit that. And let's go on to switch 3 now. Fantastic. Okay, so set protocols, RSTP interface, no, yes, interface XE 0/0/1 and 2. Commit. Okay. Once this comes up, there we go. So we should now have rapid spanning tree running on all our devices. Let's have a look at the interface. So let's do run show spanning tree interface. Okay, so straight away we can see that XE000 is a designated port and forwarding. However, we can see that XE001 is the root port. Now, because we know from our diagram, XE001 goes down to switch 3, so we're looking at switch 3's taken over as the root. So let's have a look at the bridge details. So run show spanning tree bridge detail. Fantastic. So as we can see, again, we see our own bridge priority, the root's bridge priority, and the cost to get to the root. It's cost of 2. Now you may have noticed if you watched the spanning tree videos for the service provider content, you may notice that the root cost for one link was 20,000. That's because it was for a Giga Ethernet link. Now we're using 10 gig Ethernet links. The cost on a 10 gig Ethernet link is 2,000. So it's basically a tenth of what a Giga Ethernet link is, because it's 10 times faster. So we can see our root cost is 2,000, and we can see our own details here. So that's fantabulous. All right, let's have a look on switch 2, and let's do a run show. Oopsie daisy. Run show spanning tree interface. Okay, so we can see we have a blocked interface. So the interface on GE000, which is the link from switch 2 to switch 1, is currently blocking at the moment, and the root port is 002, and that's exactly as we expect. Now, so what's happening is that we have our forwarding port, our root port, blocking, root port, and these are all forwarding because these are going to be the root. So that's exactly how we expected this to turn out. Let's have a look and see on, well, actually do the bridge detail first as well. So run show spanning tree bridge detail. Okay, so as we can see again, we can see the root cost 2,000, so it's one link away. That's fantastic. Let's have a look on switch 3, and let's do a run show spanning tree interface, and everything should be forwarding, which they are. Both ports are forwarding, and let's show the bridge detail. So run show spanning tree bridge detail, and as we see here, we can see the root's ID is 32,768 and the MAC address ending LA02, and we can see our own MAC address is the one ending LA02, and we have no root cost here. So we are the root bridge as expected. So that's absolutely fine and dandy. So let's have a look and see maybe if we can get some better pings going across now. May take a moment. Well, there you go, didn't take a moment at all. Looks like that's running absolutely fine and dandy. Brilliant stuff. And let's try PC3. Okay, so we now know that rapid spanning tree is working absolutely fine. Let's quickly jump over onto switch 1, and let's change the bridge priority on this to 28K and get router 1, or switch 1 rather, to take over as the root. So set protocols, RSTP, bridge priority, and 28K, and we do a commit. Sweet, there we go. So let's have a look at the spanning tree detail, see if that's already converged. Oh wow, yeah, that was quick. See, we can see here the bridge priority is changed to 28,000 and the MAC address F402, and it's shown that this is the same, so we are now the root. So if we go on to, let's say, switch 3, where this was originally the root, let's do the same command on here, and there you go. Now we can see we have a root cost of 2,000 to get to the root. The root bridge priority has changed, and here is our priority for switch 3's priority. So you can see how quickly rapid span tree actually converged and how switch 1 took over as the root. So there you go, that was fantastic. So as we can see, doing spanning tree on switches is exactly the same as doing it on the MX series routers. I look forward to seeing you in the next video. Hope you found this one enjoyable.